Have you ever stared up at the night sky and wondered about its deepest, darkest secrets? What if I told you there are cosmic monsters out there, so powerful that not even light can escape their grasp? Today, we're diving headfirst into one of the most mind-bending phenomena in the universe, the black hole. So, what exactly is a black hole? Imagine a star, many times more massive than our own sun. For millions, even billions of years, it burns brightly, a powerhouse of nuclear fusion. But all stars eventually run out of fuel. For these colossal stars, the end is not a quiet fade, but a spectacular, violent explosion called a supernova. What's left behind is an incredibly dense core. The gravity of this core is so immense that it collapses in on itself, squeezing an unimaginable amount of matter into an infinitely small point. This point is called a singularity. And around this singularity, a boundary is formed, the event horizon. This isn't a physical surface you can touch. It's the point of no return. Cross it, and you've officially entered the black hole. Now, let's talk about that gravity. We're used to Earth's gravity, which keeps our feet on the ground. But a black hole's gravity is on a completely different level. It's so strong that it warps the very fabric of space-time around it. Think of space-time as a stretched-out rubber sheet. If you place a bowling ball in the middle, it creates a dip. That's like the gravity of a planet or a star. A black hole, however, isn't just a dip. It's a bottomless puncture in the sheet. Anything that gets too close, whether it's a planet, a star, or a stray beam of light, will roll down that cosmic well, never to be seen again. This warping of space-time leads to some truly bizarre effects, thanks to Albert Einstein's theory of general relativity. One of the wildest is gravitational time dilation. The stronger the gravity, the slower time passes. This means that if you were observing someone falling towards a black hole from a safe distance, you would see them slow down as they approached the event horizon. Their movements would get slower and slower, their image redder and dimmer, until they seemed to freeze, suspended at the edge for eternity. But for the person actually falling in, their experience would be completely different. For them, time would feel normal. They would cross the event horizon in a flash, unaware that from the outside, they've become a permanent fixture on the cosmic brink. So, what would happen if you were that unlucky astronaut? Let's take a journey. As you approach the black hole, you'd start to feel a strange stretching sensation. This is called spaghettification. Seriously, that's the scientific term. The black hole's gravity is so much stronger at your feet than at your head that it would pull on your lower body with immensely more force. This difference in gravitational pull would stretch you out, thinner and thinner, like a piece of spaghetti, until you were torn apart at the atomic level. It's not a pleasant thought, but it's the stark reality of physics at its most extreme. Once you're past the event horizon, all bets are off. All paths lead in one direction, towards the central singularity. The laws of physics as we know them break down here. It's a point of infinite density and zero volume, a concept that our current understanding can't fully grasp. What happens to the matter and information that falls in? Does it get crushed out of existence? Or does it, as some theories suggest, emerge somewhere else, perhaps in another universe, through something called a wormhole? This is one of the biggest unanswered questions in physics, known as the black hole information paradox. You might think black holes are just cosmic vacuum cleaners, sucking up everything in their path. But they're also incredible cosmic engines. As matter gets pulled towards a black hole, it doesn't fall straight in. Instead, it forms a swirling, superheated disk around it called an accretion disk. The friction and intense gravitational forces in this disk heat the gas and dust to millions of degrees, causing it to glow brighter than entire galaxies. This is how we can see black holes. We don't see the hole itself, but the brilliant light show happening right at its edge. Sometimes, this material is funneled by powerful magnetic fields and shot out in enormous jets of energy that travel at nearly the speed of light, extending for thousands of light years into space. But how do we know they're real? We've never directly seen one, right? Well, not until 2019. That's when the Event Horizon Telescope, a global network of radio telescopes, achieved the impossible. They captured the first ever direct image of a black hole's shadow. Located in the Messier 87 galaxy, 55 million light-years away, that iconic, blurry, orange donut was a monumental achievement, confirming Einstein's predictions and giving us our first real glimpse of this gravitational monster's silhouette. We've also detected the gravitational waves, ripples, in space-time created when two black holes merge. An event so powerful it literally shakes the universe. Black holes aren't just fascinating oddities. They are fundamental to the structure of the cosmos. We now know that supermassive black holes, millions or even billions of times the mass of our Sun, sit at the center of nearly every large galaxy, including our own Milky Way. The one in our galaxy is called Sagittarius A*, and it's about 4 million times the mass of the Sun. These giants play a crucial role in galaxy formation and evolution, regulating star birth and shaping the galactic environment around them. They are not just destroyers, but also cosmic architects. From the terrifying process of spaghettification to the complete breakdown of known physics at the singularity, black holes push our understanding to its absolute limits. They are nature's ultimate laboratory, where gravity rules supreme and the rules we live by no longer apply. They force us to ask profound questions about the nature of time, space, and reality itself. And the story is far from over. Scientists are still working to unite the world of the very big relativity with the world of the very small quantum mechanics to finally understand what happens inside a black hole. Future telescopes and gravitational wave detectors will give us an even clearer picture, hopefully solving some of these deep cosmic mysteries. What do you think lies on the other side of an event horizon? Let me know your wildest theories in the comments below. I'd love to read them. If you enjoyed this journey into the abyss, please give this video a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next cosmic adventure. Thanks for watching, and keep looking up.